Hello everyone. So this is our second set of videos on theorems. Now, there's none of these are mandatory, but they're still quite important to know. So the next set of theorems all revolve around this concept, and it's Theorem 19. And what it says is the angle subtended. I'll explain what that means in a second. At the center of a circle is twice the angle at their circumference. So in other words, this angle in here is twice that angle. That's what it's saying. Simple as that. Now, the real question is, how do you prove it? Now, first of all, when I was a kid, we used to call this one the Star Trek theorem, because it has the United Federation planets logo, but you probably know what Star Trek is. You're too young for Star Trek, most of you anyway. So it's the Star Trek theorem, it used to be called. So I'll explain it, I'm going to prove it, and usually at this I'm going to prove it algebraically. Okay, so it's a very simple proof. Okay, so what you're given is a circle. You're given a circle, simple as that, with a center. Let's call it C. So there's your center C, and with I suppose 1, 2, 3, 4 lines as shown. Okay, and we want to prove that the angle at E is equal to the angle, the angle at E is twice the angle at A. Prove that the angle at E is twice the angle at A. Okay, so how am I going to prove this? Right, so I'm going to show you. So you can do it on the one that you're given. I might do it on the one that you're given. So construction. Okay. Join E to A. So watch. E to A. And let's call this one B. This one C. And join B to C. Okay. Right. So next thing I'm going to do is just, as well in the construction, I'm going to label all angles. That's important. Okay. So let's label them all. Okay. We'll start with this one. Call that one X. This one Y. This one Z. This one W. L. M. This one N. This one O. So I'm going to do some magic on this. Okay? Proof. And the proof is very simple. Okay? The angle, or the triangle AEW. Triangle AEB, and the triangle AEC, they're isosceles. Okay? Triangles. Because two sides are the radii. So if you look at it carefully, that's a radius, that's a radius, that's a radius, that's a radius. So this triangle and this triangle, they're isosceles triangle. They're not congruent, not similar, they're isosceles. In other words, they share the rules of isosceles triangles. And what does that mean? It means that the angle at Z is equal to the angle at x. And the angle at W is equal to the angle at M. And you're thinking to yourself, well, so what? Well, that really does help us. So let's put some magic into this, okay? Right. So it would be right in saying that, and I'm just going to stop using the angle symbol here, but you can use it, okay? That Z plus X plus Y is equal to 180 degrees, okay? Three angles in a triangle, 180 degrees, okay? And it'd also be true at saying that W plus M plus L is equal to 180 degrees. Again, three of them are 180 degrees. But if you look very carefully, we've said Z is X. So really that's Z plus Y is 180 degrees. And we've said that W is M. So really that's M plus L is 180 degrees. So that really means that Y is equal to 180 degrees minus 2 Z's. And really, that means that L is equal to 180 degrees minus 2 M's. Okay? But actually, I'm just going to, if you don't mind, I'm just going to change that a little bit because I want to get W. So maybe I'll make them both, if M is W and W is M, then I can make both those W's. Okay? To make this easier on myself. So, W's. So, L is now 180 minus 2 W's. Y, this fella here, is now 180 minus 2 Z's. But, interestingly, E plus Y plus L is 360 degrees. Look, the three of them together must be 360 degrees because look, it's a circle. No matter how small you make that circle, that's a circle with 3 broken into 3. So let's replace what I can. Let's replace the Y and the L. So E plus Y, 180 minus 2Z, plus L, 180 minus 2W is equal to 360. Okay, see where this is going? So E is equal to 180 plus 180, which is 360, minus 360, which is already there because you brought it over the equal sign, and then you have a minus 2Z, which is a plus 2Z on the other side, plus 2W. They cancel, so E is equal to 2Z's plus 2W's, but E is equal to 2 times Z plus W. Z plus W is A, and E is equal to 2A, which is what we said. This is twice that. And there you have it. You've proven it. Now, it's an unusual proof, but it's the proof you need to prove all the rest of the things. If you remember the last video, the very first proof, the proof that showed that if you break something into one ratio, it breaks the other one into the same ratio, you know, the parallel lines one with the transversals, that allowed you to prove an awful lot of other things. This is the same thing. This allows you to prove an awful lot of other things. So let's have a look at all the other things that it allows you to prove. Okay? So, there's a number of corollaries. I could never pronounce this word, so don't even try. Corollaries. Okay? And corollaries are things that you assume to be true based on another theorem. Okay? So let's have a look at the corollaries that come up with this little fella. So, one of the corollaries is that if you have an arc, in other words, you have a little section of your circle, like that, and if you project lines out from that circle, arc, like that. So this is this looks like the X-Men, so it does. And what this one you're allowed to show is that if you have an arc and you've drawn lines on it, then this angle and this angle will be the same, no matter how much you move it around, okay? So that's one corollary that can be gotten from the previous one, because you can work this around to prove that, you know, you can do things like joining that joining that and working out opposite angles and alternate angles. You know, that's provable. It's an easy one to prove. Another corollary that can come up, and this is one you would have done for the junior cert, is that if you have a circle and you have a diameter, then any triangle, okay, so I'll draw a number of triangles, okay, any triangle, no matter how weird it looks, all those triangles will have a right angle, okay? They'll all be right angle triangles, no matter what. Okay, so that one only would have came up in the junior cert. Another corollary of this, if I have 4 points on a circle, no matter where they are, so long as they're not the same, you know, when I join the points to form a quadrilateral, when I join the points to form a quadrilateral, opposite sides, let's call it A and B. A plus B will be 180 degrees because the four of them together, C plus D, A, B, C and D must be 360. So any two opposite ones will give you 180. So there's another kind of corollary from that. Okay, so they all come from this one. They're all derived from this one. Now, you don't have to prove them, but knowing those rules would be very helpful. I like to remember that one. Sometimes it's the Fox's Ear one or the X-Men one. Okay, that one, I don't have names for them, but like there's my Star Trek one and my kind of Fox's Ear or X-Men one. They're two handy ones to kind of know. Okay, so final thing today to look at is, I suppose, tangents and chords. So again, I'll just draw a quick circle here. And again, this is something you would have done when we were doing coordinate geometry of the circle and of the line. But if you have a chord, so think about this. If you have a chord and then you have the center of the circle, okay, then any line that goes perpendicular through the chord bisects the chord in half. And the converse of that is also true. So the converse of that would be true, that if you find the midpoint of any chord and you find the perpendicular line equation through that, that line will also go through the center. Now, how would you prove this one? There's lots of different ways you can prove this one. My way of doing it is using isosceles triangles. If I construct lines here, they're the same because they're radii. Okay, so even if you don't know that they're the same, you know that this is an isosceles triangle, and you can create two other isosceles triangles that have the same, so they become congruent, and congruence triangles have the same distance on each of the sides, because that'd be common. So look, side, 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 and drawing a line, a perpendicular line, would make them a right angle, and that would give you congruency, which means those two lines would be the same distance apart, because congruent means that they're all the same. Okay, trying to think, is there any other ones? The only other one, again, this is a coordinate geometry one more than anything else, is that I would draw any tangent, then the point of contact, if it goes through the center, they're perpendicular to each other. Okay, and again, you can prove that very simply. Okay, and there's a nice little extension on that, in that you can join the center to any point outside on that line, and you've got a right angle triangle. As long as you know the radius and either that distance or that distance, you can find the alternate distance or the alternate angles using trig. Okay, so there's a couple other ones there, but there's a few little bits that are on the circle. Okay, hope that helps.